Okay, today we're going to be discussing AI engineering or AI systems engineering. This is an emerging field, and I think it's important to know about it. Some of you may be interested in it, but at least you should know about it. So that's what we're going to be discussing today. Let's dive in. Okay, as we begin, one of the first things I want to say is if you want to learn how to code, check out codecademy.com. Use the link in the description below for a 50% discount on your first purchase. Codecademy.com. All right. So traditionally, backend engineering has been, very specific. I made a video talking about backend engineering, but right now it's going through a metamorphosis. It's changing quite a bit. Traditional backend engineering still exists, but a new branch of backend engineering is emerging, and this is what I think will be called AI systems engineering. So that's what we are talking about, and let's go in. So the main thing is that backend engineering used to be about APIs, and then now it's about building intelligent systems that has reasoning and decision making capabilities. Okay, so it is no longer just building an API with your controllers and all that, but the entire system is intelligent, can retrieve data when it's necessary, and then use that data to synthesize a response to a user or another service that's requesting it. So that is kind of the gap, right? Going from the traditional way to kind of contextual, non-deterministic approach, and an entire system that can reason and make decisions, and then can also integrate real world data. This is what this new field entails. So the main thing driving it is the capability of AI now. These days, AI models can handle complex workflows that, like before, you just couldn't do it. For example, you couldn't just chat with a user in natural language for the user to say what they want, like doing something like let's say it's a booking app or reminder app or something like that, like a very complex query. Okay, remind me about this, but only in these conditions and those kinds of things. Before, you'd have to do like a lot of rule-based stuff, but now it's with the capabilities of AI can really understand what the user's true intent, and then be able to do the thing, make the booking, reminder, whatever the case may be. And more companies want this like AI integration in their systems for customer service and many different scenarios. So this is kind of, there is a huge demand for engineers who can build intelligent backend systems, and that has created this gap for and created this opportunity really for like someone like you to also become that AI systems engineer. So essentially, you are building an AI powered backend. Okay, AI powered backend. You are going to be working with agents, tools, RAG. RAG stands for Retrieval Augmented Generation. And then orchestrators. By orchestrators, what I basically mean is like a main agent that kind of runs the flow, decides what tool to call or who to hand off to and everything, and then also responds to the user. So the entire system should be able to reason, act, and integrate with real world data. So like I said, you're going to be dealing with agents, tools. Tools are functions that give the AI more capabilities to do more stuff. For example, AI in itself, like raw ChatGPT or raw GPT model, doesn't know what day it is. For the AI to know, okay, like this is today's date. Like if the user says something like, remind me 3 days from now to walk the dog or something like that, assuming you're into that. Traditionally, like it would have had to be like a rule-based thing, but now AI would need to know, okay, first of all, what's today's date? So then if you have a tool, it would call that to get the actual date and then call another tool to set the reminder, that kind of thing. So that's what tools enable, like traditional like raw AI models to have more capabilities. And I've already kind of mentioned what RAG is and then what orchestrators are. So this isn't just backend. It is without fixed APIs, without rule-based processing and everything. But this is rather contextual, non-deterministic responses. You can build an AI system or an AI agent that like is fully autonomous, and the level of autonomosity the level of autonomy, that is the word, my goodness. Depends largely on what the context is, right? It could be fully autonomous or like, it could be well constrained and everything. Depends on what you're building, but it should be able to handle ambiguity, incomplete information, and things like that. It can be like extremely powerful if built right. So yes, so these are some of the things that AI systems engineers can create. So sophisticated, intelligent applications, so that go beyond traditional backend functionalities. So that you will have multi-step workflows, agent logic, knowledge-aware systems. By knowledge-aware systems, what I basically mean is, let's say you want to have ChatGPT that answers questions on your behalf, right? Now, ChatGPT, the GPT model in itself it's just trained on general information. It's not really trained on you and your data. So if you want it to be able to answer questions about you, it would need to be, that is what language aware systems are, like being able to extract data from some document that has everything about you, your life and your life's experience and everything. So you would, go there, get that information from that external source, and then add it to its understanding of how to respond to users and then generate a response. So the core parts of an AI system, please don't mind my slides. I tried to use AI to generate these slides. It did a decent job, and I don't really have the luxury of time to try and edit everything. So just bear with me with some of these things. But anyway, you have some workflow modeling, orchestrators, tools, observability. It's all about, looking at like traces, like all of the work that AI was doing for a particular workflow, seeing what tools are called, analyzing the performance, what were the responses they did, run into errors and stuff, what can you do to fix them? So that's what this is about. Then we have mentioned RAG a few times, then there's safety and evaluation, then state management as well. So key aspects of workflow modeling is like designing a workflow. These are things that you would need to understand. I can't really explain the whole thing in this video, so I'm just going to mention things that you would need to understand, and then on your own, you can go learn about it. There are lots of resources available online. So there's the user request. You detect the intent of the user. You retrieve some knowledge from the database, you make some tool calls, and then you generate a response. So this is what kind of like a workflow looks like, So you need to know, okay, what is this user trying to do? Is the user trying to make a purchase, or do they just want information? If they want to make a purchase, take them through the purchase, workflow. If they want information, then, you retrieve the knowledge about, these are the products that we have and things like that. You can make some tool calls for specific things, and then you generate the response. So this slide kind of talks about the same thing. I'm not going to go into it. And then tools, like I said, enable agents, gives agents more capabilities. Tools can help you, integrate stuff like making bookings, modifying customer data, modifying memories, doing some analysis and things like that. Tools can really explode the capabilities of your AI system. If you give a model tools and it can call those tools, then it becomes extremely capable, extremely powerful as well. So next thing, I've already mentioned RAG. So in more detail, RAG basically is a user message comes in, it is broken down into chunks, it's split up, broken down into chunks, and then embedded, right? And an embedding is kind of like in a very extremely high level definition of what an embedding is. It's kind of like a numerical representation of a word or a token. Let me just Google what an embedding is. An embedding is a way of representing complex data like words, images, or sounds as a list of numbers, a vector, in a simple, organized way. This representation captures the essential characteristics and relationships. If you go to this link, maybe they will do a better job of explaining these things. So, yes. So here's two words. Dad and mom would be represented as embedding. So dad is all of this, and then mom is all of this, even though there are similarities, it's clearly different. So these are embeddings. So every word or every image, whatever, can be embedded. And then if a new thing comes in, if a new word comes in or a new phrase comes in, what RAG is going to do, what's like RAG is all about, is convert that new thing also to this embedding, and then use the both of the vectors to compare what information do we have that is extremely similar to the new vector that we have, and then gather that, and then I can go into a full video about embeddings, but I'm trying to do kind of like off the cuff explanation as we go right now. Yeah, so you can read more about this stuff on your own. So before we continue with the video, let's take a word from today's sponsor, API Layer. So what's API Layer? Simple. Think of API Layer as a massive toolbox. They have a whole bunch of APIs, which basically means they give you the keys to integrate extremely powerful features directly into whatever you're building. So if you're building an app, a website, or just doing some data crunching, they make adding complex features really, really simple. The whole idea is to make your life easier as a developer, and who doesn't love that? Now, API Layer has a ton of APIs, but two specific ones that I think you should really pay attention to, especially if you're thinking about building real-world projects for your portfolio so that you can land your job, are Market Stack and IP Stack. Let's talk about Market Stack. If you're building or even thinking about building anything finance related, a stock tracker, a portfolio manager, or just pulling some real-time market data for a project, Market Stack is your go-to. It gives you literal real-time and historical stock data from over 70 global exchanges. This is the kind of data you need to build serious applications. It's solid, trust me. So the second one we'll talk about is IP Stack. This one is wild. If you want to know where your website visitors are coming from, or need to even detect the currency, or maybe you want to block some shady IP addresses in order to keep your app secure, IP Stack does all of that instantly. It's a powerful tool for personalizing user experiences or just making stuff safe. Very useful, believe me. So why bother with API Layer? It's simple. They take the headache out of integrating complex stuff. They are reliable, the data is accurate, and that means you can focus on building the meat of your application. You don't need to be wrestling with data sources. If you're building out your portfolio, trying to get a job, or just making something cool, using a service like API Layer can seriously elevate your projects. It's smart engineering, plain and simple. If you're ready to see how these can boost your projects, head over to apilayer.com, marketstack.com, or ipstack.com. I've put all the links right there in the description for you. A massive thank you to API Layer for supporting Tech Trek. Now let's get back to the video. Let's get back to what we're talking about. So embeddings do vector search and So you need to understand these things. But trust me, it's not difficult. It's not too difficult. Okay. This talks about kind of more details on the RAG flow. So user message, so that's queries or prompts, is split into documents, split documents into chunks, converts chunks into vectors, then do a vector search to find relevant chunks. That is what I was trying to explain. Find relevant chunks and then feed it back to a large language model to generate a response. And then next thing I'm talking about is guardrails. So guardrails make the AI systems more like reliable. Think of a guardrail as, after let's say an LLM generated response, a guardrail enables you to check, for example, is this response in the right structure? Does this response answer the user's question? Does it include any harmful instructions? So it's usually going to be another LLM that checks the work of the LLM. So that is a guardrail. Just like evaluates the thing, that the response that has been made, and then if it passes all of your safety checks, then it can be returned to the user. Another thing you need to understand is managing state in AI systems. So memory, understanding memory, long-term and short-term memory, context, storage, long-term and short-term context. So like think of context like if you've ever used deep research on ChatGPT or Claude, I think Gemini has one now. You need to it can take maybe 25 minutes or so, and all of that, like as it's gathering data and everything, you can't store all of that in like memory. You need some kind of state to manage all of the queries, that all the documents or the things they are putting together and all that, and then be able to generate the response. So you need to know how to do that. Now with all these things, you You don't need to be an expert at them because this is like emerging cutting edge field, so you need to know enough to build stuff, and then you learn as you go. Like, it's very important, like you just be learning a lot, as opposed to just like learning once and forget about it. You need to be, on Twitter, X, following people who talk about these things, reading articles, blogs, all that. Yeah, I have mentioned tracing a bit. And then, so this is observability. I have mentioned some of these things. One of the things that you'd be doing a lot is just going and then reading the chats that people are having with AI, just to understand how your AI system is performing and, knowing where you need to improve. Yeah. So, skills. I'm sure you already know the skills you need, but this is going to kind of make it more organized for you. So you need to understand backend fundamentals, Python or Node, APIs and databases, Redis and all that. Then you need to then know about large language models, function calling, token management, prompt architecture, how to write, good system prompt, how to make sure that your AI model is like following instructions with prompts and stuff. It's always good to go to the model provider. Let's say GPT-5 prompt. Is it prompting guide? That's what I'm looking for. So OpenAI and other model providers give out these, like, write these articles and things about the prompting guide. So you can, like, you would have to be reading these things, like, oh, like this is prompting for less eagerness. Okay, this is what I need to do. Like, all of this kind of stuff is what you'll be doing regularly. So LLM knowledge. Then understand RAG pipelines, vector databases. So before, in the last video, I talked about, backend and then databases. I mentioned SQL and NoSQL databases. Another kind of database that you'd learn, that you would absolutely need for building AI systems, AI powered systems, is vector databases, because the embeddings will be stored in vector databases, and then you need to know how to retrieve them and all of those kinds of things. And then on the orchestration side, you can know about either, not all, but either LangGraph, OpenAI Agents SDK, other kinds of SDKs that enable you to build, like, put all of these things together. Then evaluation, so validating outputs, guardrails, and then systems observability. So yeah, you still need all these, like, backend understanding of these backend systems. Async logic is extremely important. Like, you need this. This is important. And then, yeah, all this stuff. So the specific AI skills that you need, we've already talked about this, so I'm not going to repeat myself. And then these are frameworks. So LangGraph, OpenAI Agents SDK, Llama Index, So let me go to OpenAI Agents SDK. So this SDK allows you to build like agents, or the systems that we've been talking about. You can create an agent, give it instructions and stuff, tools. So this is kind of how it looks like. And you can have multi-agent systems. You look at this, so you see something like this, our practical guide to building agents. Click on it. And then, go ahead and read stuff like this. It defines what an agent is. So agent systems that independently accomplish tasks on their own behalf. When you should build an agent, like, there's so much information here that you can learn about. So this is basically what you'll be doing. Like, it's hard to get a course for all this stuff. I mean, I can work on something, but a lot of the work will have to be just reading these kinds of documents. So let's look at LangGraph. So for LangGraph, you go to langchain.com. It has, like, there's a lot of stuff. There is a lot of stuff. Choose a tool. The tool that you choose depends on what you're building. Don't just, like, go pick something. So they have, like, LangChain, LangGraph, DeepAgent, and all that stuff. And then, So after backend, LLM, build a RAG project, use these AI systems that we spoke about, then do some evaluation. Hopefully not too complex. There is a lot to learn, but I'm sure you can do it. You can definitely do it. So you can build a WhatsApp AI booking agent. These are like project ideas. You can build an email triage assistant. So build a system that categorizes, prioritizes, and responds to emails using AI, eternal AI ops agent assistant and everything. Now, notice I haven't said anything about N8N. Of course, you can kind of piece some of these things together with N8N, but that is not, that's not what I'm talking about. This is talking about building like a fully fledged AI system, not just like piecing some stuff together. Even though you can build powerful workflows with something like that, something like N8N, there is a limit to the kind of system that you can build with stuff like that. So I'm talking about being able to engineer your own thing from scratch. It's not really from scratch because like you're using a lot of tools, but I'm sure you get what I mean. So backend engineers are extremely important. Like this kind of field, if you're a backend engineer and you are interested in AI, you are like perfect, literally the perfect candidate for this, because you understand system design, data flow. It's going to be a natural transition to the AI world. But if you're not a backend engineer already, like I said, you'd need to understand those fundamentals and then move into this. But it's not impossible. I wasn't a backend engineer. I was largely front end. I mean, I was full stack. Like, I am full stack, but let's say 70% of my work was front end. But since I started building these kind of AI systems, and this is what I do. This is like 90% of my work right now is this stuff. Everything I've been talking about in this video is what I do on a daily basis, about 90% of the time. So I was just like, even though I was heavy front end, I was still able to transition easily because of the AI interest and everything. So I have picked up more backend skills along the way, like understanding more backend stuff. But my work is mainly the AI part of the backend, not really the full backend. All this stuff is something I'm working with, so I have an idea of what I'm saying. I think that it is going to be extremely important. Like more and more companies that are like more and more jobs that you're going to be seeing in the future are going to be around this stuff. And you need, if this is kind of the thing that you use to future proof yourself. Of course, even this role is like evolving. It's evolving quite a bit. Like there are always new techniques and stuff that I am learning, almost on a daily basis now. So you need to be like very interested in learning. Very, very interested in learning. So yeah. Final thoughts. You can do it. That's the last time we say you can do it. If you're interested in it, get started today. But yeah, you can do it. All right. Anyway, thanks so much for joining and watching this video with me. Let me know what you want me to talk about next. There is, an abundance of things to discuss, but let me know what your ideas are. If you want me to dive deeper into this AI stuff as well, let me know. Otherwise, thanks for joining. Share this with somebody. I will see you next time. Bye-bye.